So in our first examples, we were able to either take the square root of both the numerator and the denominator, or we were able to cancel out the denominator and just have the radical expression without a denominator. But that doesn't always work. We don't always have a perfect world where things work out. And there are some rules about having radicals in the denominator. And basically the rule is you can't have that. So you cannot have a radical in the denominator. Now you might say, but they gave that to us, Yeah, they can start out, but we have to simplify it so that it doesn't have a radical in the denominator. And we call this rationalizing the denominator. Also, you can't have a fraction. I'll use the word fraction. You can't have a numerator and a denominator under the radical. And again, you might say, but we did that. We did, but we were able to simplify them, and so it worked out. But in the end, when we're done with our final answer, we can't have these things, okay? So to get rid of the radical in the denominator, we have to, what we say, rationalize the denominator. So that's what these next few videos are going to be talking about, is rationalizing the denominator. And what we mean by that is we're making sure the denominator does not have a radical in the final answer. It's a rational expression instead of a radical expression. Okay, so the two kind of sound the same. So let's say you have something like a over the square root of b. Well, you can't, so we can't have that. What we do, in this case, we would multiply by the square root of b. And we would do it to both the top and the bottom, because we're allowed to multiply by any non-zero expression, as long as we do it to both the numerator and the denominator. We do that when we get common denominators with fractions or rational expressions, so that's okay. But watch what happens when we do that. Then in the numerator, we get a times the square root of b, which is fine. But in the denominator, we get the square root of b squared, and that we can take the square root of. So then we have a times the square root of b over b. And then that would be rationalized. We'd say that denominator is rationalized because it no longer has a radical in the denominator. So that's kind of the goal that we're going for here. And I'll go through the examples. Now, you might have a question here about the b here and the b there. And here's the rule. If they're both inside the radical, you can cancel. If they're both outside the radical, you can cancel. But if one's in the radical and one's out, you can't cancel. Okay? So that's kind of the brief explanation. We'll talk about it as we go through these. So here's our first one. We have 5 over the square root of 3. And we can't have the square root of 3. So in the denominator, we can have a square root of 3, but not in the denominator. So we have to think, okay, how can I get that 3 to be a perfect square? And I'd have to multiply it by another radical, and I want to put a 3 in there so that I have 3 times 3, or 3 squared, and then that I can take the square root of. So whatever I multiply in the denominator, I also multiply in the numerator. And then that's going to give me 5 square root 3 over, I'm going to write this out, the square root of 9, because we would multiply those radicals. And then we know the square root of 9, that's why we did it, so we get 5 square root 3 over 3. And we're done. Can't simplify. 3 doesn't go into 5, and you can't cancel the two 3's because one's in the radical and one's not in the radical. Okay. So here's another example. We have the square root of 3 over 32. Now it's all under one radical, and that's fine. We can have that. If I could simplify that fraction, I would. But there isn't an integer that goes into both 3 and 32, so I'm out of luck that way. If I could take the square root of 32, I would. But I can't do that either. It's not a perfect square. So how would I get 32 to be a perfect square? Well, 64 is a perfect square. So I could multiply by a 2. Now I am allowed to do this underneath. I could split it up into two separate radicals and do it like I did on the last problem, but I can go ahead and work with a fraction underneath. That's the same thing as just, we call it building fractions. So I'm getting a denominator of 64. Why do I want a denominator of 64? Because that I can take the square root of. Okay, so then that gives me the square root of 6 over 64. Now if I split them up, square root of 6 over the square root of 64, the denominator, I can take the square root of that. And so I get the square root of 6 over 8. There's nothing I can do to simplify that because the 6 is under the square root, but the 8 is not. So this one's done. So kind of a different twist on that one a little bit. Okay, now we have one where it has a 2 in the denominator under that radical and also an x. So I'm going to make it a little bit bigger. 2 over the square root of 2x. So I've got to think about how could I get that 2 to be a perfect square, and how could I get that x to be a perfect square? Well, in this case, I could multiply by the square root of 2, because 2 times 2 would give me 4. I'd have 2 2's, and that would, I could take the square root of. And if I had another x, that would give me x squared, and that would work also. All right. Now, sometimes students at this point say, oh, you just multiply by whatever the radical is in the denominator, and you do that. Sometimes we do that, but sometimes that is not the most efficient way to do the problem, okay? So we'll see that in some more examples coming up. In the numerator here, I have this 2, and I have the radical 2x. In the denominator, I'm going to write this out. I'm going to write the multiplication out so you can see it. It's the square root of 4x squared if I multiply those radicands. But then that I can take the square root of, which is why I wanted to do it in the first place. And I get the square root of 4 is 2, and the square root of x squared is x. Now this one has a little bit more to it. So you might remember, and I said in this video, if they're both under the radical, you can cancel. And if they're both outside the radical, you can cancel. But if one's in the radical and one's out of the radical, you can't cancel. So I've got a couple 2's going on in this problem. I have 3 2's, right? This 2 can cancel with that 2 because they are both outside of the radical. And one's in the numerator and one's in the denominator. The x, though, the x here, that can't cancel with that x because the x in the denominator is not under the radical, but the x in the numerator is under the radical. So what's my final answer going to be? The square root of 2x over x. All right, these will get a little easier as we do more of them.